So how do we measure the amplitude and period of the tan function? Well, the tan function is different from the sine and the cosine in terms of its amplitude, and that is, it doesn't have an amplitude that we can talk about. Now, when we talked about amplitude, it had to have a maximum and also a minimum value. So you can see here, for example, at this point we have a maximum value here, but we don't have any minimum. It just heads off to infinity. And that would be the same for any other point that we picked along the tan function. A point up here would have a maximum, but there would be no minimum. So it doesn't make any sense to talk about the amplitude of the tan function. But we can still put a number in front of the tan function. For example, we could write 5 tan x or 10 tan x. But that number no longer represents an amplitude. It represents the, if you like, the gain or a stretch of the function. And that's different from the amplitude. So when we talk about amplitude, we talk about sines and cosines. Now what about the period? Well, the period is whenever the function starts to repeat. Now, we know that 360 degrees is at this point here, which is 6.28, which is 2 pi radians. So this is 360 degrees at this point. Now, if we look at the tan function and we see whenever it actually repeats, well, it heads off to infinity up here, comes from minus infinity and goes back to the 0. And it's at this point here it then repeats off to infinity and then up towards 0. So we can see the repetition is at this point here, which is halfway along, which is pi radians or 3.14. So this point here is 180 degrees. So the difference between the sine and the cosine and the tan is that the sine and the cosine has a period of 360 degrees, but the tangent function has a period of only 180 degrees. So it repeats here twice within that 360 degree cycle. So let's go ahead and we will put in the value a tan bx and we'll see the function changing. And then we'll go and look at a little example. So we have our function written here. F of x is a1 tan b1x. So the b1 here is going to give us the period. But remember, there is no amplitude in this. But the a1 is still going to stretch the function. So we can see the function being stretched here. But even though the function is able to be stretched and swapped around like this as well, it's no longer proper to talk about it as an amplitude because there's no maximum and minimum value. Now again, we can change the period here, and you can see if I was to change this to a value of 2, the period at the moment is going to be 180 degrees, which is this point here, which is pi radians. And if we change that to a value, for example 2, you can see here that the period now has changed, so it's no longer the value of 180 degrees here, which is pi. It's going to be half of it, so it's pi by 2. So let's look at a little example of using the amplitude and period for the tan function. I have drawn out a tangent function here, and we have to work out what the period of this function is. Now we know the period is when the function repeats. So we can see this heading off to infinity, and it goes from minus infinity up to 0. So we can see it's going to repeat over this distance here. And then you can see it repeats again and again and again, and it just keeps repeating. So the period here is somewhere just below 1. Now that's in radians. But if we were to look at this, we know that 360 degrees is going to be 2 pi radians, which is this point up here, 6.28, that's 2 pi radians. So we can look and see how many times it repeats in this 360 degrees. So it's going to repeat once, twice, 3, 4, 5, 6, 7, 8 times. So it repeats 8 times in 360 degrees. So we could say here that the period then is going to equal 360 divided by the 8, which is equal to 45 degrees. So this repeats every 45 degrees, which is this point here, and that's another 45, another 45, and we keep adding all those 45s up until we get to this point here, which is 360. Now, alternatively, what we could have done is we could have started off with a function, and we could have said, let's say we have the function tan 4x, and we were asked to find the period of this function. Well, we know the tan function repeats after 180 degrees. So therefore we could say that 4x is equal to 180 degrees. So we can say that x is equal to 180 divided by the 4, which is equal to 45 degrees. Now don't worry if you're not following some of this, it'll all become really quite apparent whenever you start working through examples.